graphing log functions, these are inverses, okay? Inverses of our exponential function. Okay, so all of these graphs are going to mimic this idea. Okay, that's our, when we're going to be looking at natural log. Okay, so it's a complete inverse of our exponential. It's always going to look like this. And instead of having horizontal asymptotes, we're going to be having vertical asymptotes. It will always be at 0 unless there's some sort of transformation. So looking at number 10, okay, this is going to tell us to multiply every y value by 2 because f of x, that means y. Okay, and then the ln of x minus 1, this is what's telling us what's happening with our domain. This is also telling us that we're going to go left 1. And then negative 4, that's telling us to go down 4. Okay, so on our graph, we're going to go left 1, and then we're going to go down 1, 2, 3, 4. This is our new origin. This is where we start our points. So again, we're going to make all of these transformations. We're going to look at everything that's happening to a log function. That's just to get our new origin. Now we're going to just think of it as a log function. So our asymptote has to go through the origin, and it's going to be vertical. So it's going to be x equals negative 1, because we're back at negative 1. And then our points, usually it's 0, 1, but just like a log, L, O. Think of that. It's going to totally flip-flop and be inverse now. So it's 1, 0, E, 1. And the reason it's E is because it's a natural log, and there's usually that base, which would be E. Okay, and then 1 over E, negative 1. But because we need to multiply everything by 2, and we're multiplying our y values, okay, we're going to multiply by 2 to the 0, to the 1, and to the negative 1. So our actual points that we will plot from our new origin will be 1, 0, that's going to stay the same, E, 2, and 1 over E, negative 2. So that 2 is basically stretching out our function. So starting here, we're going to go 1, 0. E is going to be 2.7, so 1, 2.7, up 2, and about a third down 2. And it's going to try and hug the asymptote and keep growing, growing, growing. So the domain, again, is always reading our x-axis, and there's nothing happening over here. Nothing happens until negative 1. So it's negative 1 to infinity, and then the range is going to go down forever, so it's starting all the way down at negative infinity, going to go all the way up to positive infinity. All right, and that's going to be the range also for this one. Range for log functions are always negative infinity to positive infinity. Domain depends on where the asymptote is. All right, so here we look, there's a negative, so that's going to mean multiply all of our y values by negative 1. There's nothing going on with the x, there's no movement. If it was in parentheses, then we would have to shift it left or right. And then this negative 2 is going to tell me to go down 2. So I'm going to go down 1, 2, and this is going to be my new origin. And then my asymptote is going to go right through the origin. So the asymptote is x equals 0. And my domain will also be from 0 to infinity. So now we just got to think about the points. And we did all of our transformations. The only thing we have to now apply is our negative value. So again, usually it's 1, 0. It'd be E1 and 1 over E negative 1. But we need to multiply everything, every y value, by the negative 1. because this is what's in front over here. So then it's going to turn into 1, 0, e negative 1, 1 over e positive 1. So we'll graph that. And then e, go down and up. And that makes complete sense because that negative also tells us that it's going to flip our graphs. And this is completely flipped from what we see above. All right, that's it. I will see you guys tomorrow.